Question number 51. What is the recommended voltage level for pin type insulator? This question is asked in Mahatransco AE exam year 2022. 5 options are given. Now we know that there are different types of insulators that are used for supporting the conductor. Out of that, one of the insulator is a pin type insulator. So this pin type insulator is used in a distribution network, and the recommended voltage level for pin type insulator is 33 kV. So we use the pin type insulators up to 33 kV. More than 33 kV, usually we don't use a pin type insulator because its size will be very large and there are chances of puncture. Apart from pin type insulator, there are other insulators like suspension or disc type insulator. So this suspension type insulator we can use for a voltage level greater than or equal to 11 kV. In some cases, even for 11 kV, we use suspension insulator. And if voltage level is at the transmission range, that is 66 kV, 110, 132, 220, 400 or 765 kV, everywhere we use the suspension insulator. So suspension insulator can be used in a vertical fashion or horizontal fashion. So if we use the suspension insulators in a vertical configuration like this, and here there is a conductor, then this type of arrangement is usually known as a suspension type insulator. But if we use the disc in a horizontal configuration like this, and here there is a conductor, then this type of configuration we call it as a strain type configuration. This one is a suspension type configuration. So suspension type configuration is used during the normal run, whereas whenever there is a deviation, dead end, river crossing, road crossing, in those cases we use the tension tower, and in tension tower we use the strain type insulator. But in both the cases we use the disc insulators. So in both cases disc insulators are used. Now there is another type of insulator which is again used in a distribution type network, that is a shackle insulator. Shackle insulator is used for 440 volt distribution network. So next one is a stay insulator. So stay insulator, it is used in a stay wire. And why stay wire is used? So stay wire or guy wire is used to provide support to the pole, especially in a distribution. So in distribution we use the poles, and in order to provide support to that pole we use a stay wire. In that stay wire, in order to prevent the leakage current, if any, from pole to the ground, we use a stay insulator. So usually we use a distribution pole at 11 kV or 33 kV. We can consider this at 11 kV or 33 kV, because for transmission we use a tower, and for tower in most of the case we don't use stay wire because of their strong foundation. They don't require a stay wire for support. There is one more insulator which is the post insulator. So that is used to connect conductor to the bus bar in a substation. To connect, or we can say to fit the conductor to the bus bar in substation, we use post insulator. For all the voltage levels we use this post insulator. This question is asked in Mahatransco exam, assistant engineer for 2022 exam. So next question, question number 52. For a load flow solution, the quantity is normally specified at voltage controlled bus. As we are aware, there are different types of buses in a power system. Out of that, here it is asked for a voltage controlled bus, which quantities are specified. 4 options are given. So if we prepare a table, so first type of bus in a power system, that is a slack bus, which is also known as a swing bus or reference bus. So here two quantities are specified, that is magnitude of voltage and phase angle of that voltage, that is delta. The unknown quantities are active and reactive power injected at the bus. So P and Q are the unknown. The second is a voltage controlled bus. It is also known as a PV bus or generator bus. So here what is specified, as the name itself says, PV. So active power injected P and the magnitude of the voltage V is specified. The unknown quantities are Q, that is the reactive power, and phase angle of the voltage are the unknown quantities. Sometimes, remember, the maximum and minimum limits of reactive power are also specified here. Maximum and minimum limits of reactive power are also specified. And the third bus is the load bus, which is also known as PQ bus. So here, as the name says, active and reactive power injected are mentioned, whereas magnitude of voltage and the phase angle delta are unknown here. So remember this table. What are the different types of buses, which quantities are specified and which quantities are unknown. The highest number of buses in a power system are load bus. So load bus, about 90 to 95% of buses in a power system are load bus. The slack bus is only one. In a given power network, we consider only one bus as a slack bus. So usually a generator with highest capacity is considered as a slack bus, the bus to which a generator of largest rating is connected, that is the slack bus. Other buses are voltage controlled bus or PV bus, so that we can consider about 5%. So about 95% buses are load bus, roughly 5% are voltage controlled bus, and slack bus is only one. It's not 1%, only one. Irrespective of the size of the network, we take only one bus as a slack bus. Next question, question number 53. The surge impedance of 50 miles long underground cable is 50 ohm. For a 25 miles length, it will be. So how much will be the surge impedance for 25 miles? If for 50 miles it is 50 ohm. So what is the surge impedance? In order to understand that, we need to consider the characteristic impedance first. ZC, it is given by under root Z by Y, where Z is the impedance, series impedance, and Y is the shunt admittance. So we can write Z as R plus JXL, and XL is nothing but omega L, and Y, shunt admittance, it will have two components. One is the conductance and another is the capacitance. So G plus J omega C. Okay, of course we can express this in terms of capacitive reactance or capacitive susceptance, but in simplified form we can write it as G plus J omega C. Now if line is lossless, so practically in power system we consider line as a lossless, because resistance R, it is approximately 0 and the shunt conductance is also approximately 0. If this is the case, then characteristic impedance ZC, it will become as a surge impedance. So here we can write surge impedance. So same equation, it will be converted to surge impedance ZS. So that will be equal to under root. If we put R as 0, G as 0, so in numerator it will be J omega L divided by J omega C. So this J omega will get cancelled. We will get a surge impedance as under root L by C. So this is the equation of surge impedance, and this is the equation of characteristic impedance. In many books, both the terms are used interchangeably, but there is difference between this. Surge impedance term is used for a lossless line. Now what is the equation of L? So we know that L is given by mu naught upon 2 pi ln GMD by GMR, where GMD is geometric mean distance, GMR is geometric mean radius. So its unit will be Henry per meter per phase, and the capacitance of line is given by 2 pi epsilon 0 upon ln GMD by GMR. So units will be farad per meter per phase. Here remember GMR for a single conductor it will be R dash, that is 0.7788 times R, but in case of capacitance calculation GMR it will be simply R. Now if you observe the equations of L and C, so in both the equations this inductance or capacitance, they do not depend on the line length. So what we can say, L and C, they are not function of line length, therefore ZS is also not a function of line length. Therefore even if length is halved, or length is doubled or changed, ZS will remain fixed. So for 50 miles, if ZS is 50 ohm, then for 25 miles also ZS will be 50 ohm. So correct answer, it will be option B, that is 50 ohm. Now on which parameter this ZS will depend? It depends on L and C, and L and C depends on GMD and GMR. That is, it will depend on the size of the conductor, the distance between the adjacent conductors, geometrical configuration and so on. That will decide what will be the L and C. That will decide what is the value of surge impedance ZS. Now remember, ZS surge impedance, it is about 400 to 600 ohm for a transmission line, whereas for underground cable it is about 40 to 60 ohm for underground cables. So why ZS is less for underground cable? Because of the fact that ZS is inversely proportional to root C, and for cables we know that capacitance is more, inductance is less. So as denominator is more, ZS will be less. For transmission line, L is dominating, whereas C is less. So therefore ZS it is more as L is more. Moving to next question, question number 54. A 3-phase 33 kV oil circuit breaker is rated 1200 ampere, 2000 MVA, 3 seconds. The symmetrical breaking current is. So 4 options are given. This question is asked in GATE exam year 2010. Now here if you observe, whatever 33 kV is there, so it is basically the rated voltage of that breaker VL. Now whatever this 2000 MVA is there, it is nothing but its breaking capacity. So S we can consider as 2000 MVA, and whatever this 1200 ampere is there, it is the rated current, I rated. Meaning is that the circuit breaker can carry this current continuously without getting damaged, without getting operated. It can carry this current 1200 ampere continuously. What is this 3 second? So this 3 second is called as short time current rate. Okay, so this 3 second is the short time rating. So what does this short time rating means? It means that this circuit breaker can carry a fault current continuously without getting damaged for 3 seconds. Okay, otherwise if large fault current persists beyond 3 seconds, the circuit breaker may get damaged. Now here what is asked, the symmetrical breaking current we need to calculate. For that we can make use of this breaking capacity. So breaking capacity or symmetrical breaking capacity S is given by root 3 into VL, rated line voltage, into symmetrical breaking current, I symmetrical breaking current. Then this symmetrical breaking current we can write as S upon root 3 into VL. So that is equal to, now how much is S? It is 2000 MVA. We can convert that to kVA by multiplying with 10 raised to 3, 1000. So divided by root 3 into VL. VL is 33 kV. So we have multiplied with 1000 to the numerator in order to convert MVA to kVA. As denominator it is in kilo kV. So if we solve this, the symmetrical breaking current that we will get as 35 kA. If making current is asked, then we need to multiply this with 2.55, because making current is 2.55 times the symmetrical breaking current. They have asked the symmetrical breaking current. So correct answer it will be option C. Moving to next question, question number 55. In order to have lower cost of generation, 4 options are given. The load factor and diversity factor should be low, load factor and diversity factor should be high, load factor should be low but diversity factor should be high, and vice versa. Load factor is high and diversity factor is low. This question is asked in engineering service exam year 2030. What is the definition of load factor? So load factor, it is a ratio of average load to the maximum load. Now load factor, it should be as high as possible, because if load factor is high, it means that load is using electrical energy very efficiently. So higher the load factor, the efficiency will be more. So therefore the cost of generation it should be low if load factor is more. Now the second, about the diversity factor. Now what is the definition of diversity factor? It is the ratio of sum of individual maximum demands divided by coincident maximum demand of a power station. Now, in order to have lower cost of generation, this diversity factor, it should also be increased, because if diversity factor is more, it means that coincident maximum demand, it is reduced. And if coincident maximum demand, that is the maximum demand that is likely to occur at any time on that particular power station, it will be reduced. And if coincident maximum demand is reduced, obviously the plant capacity required, it will be reduced, because various loads are having their maximum demand at some other instances. Not all the loads are on at all the time or at a particular time. Then coincident maximum demand will automatically reduce. If it get reduced, plant capacity required is less, and if plant capacity required is less, the investment required on a particular power plant, it will be less. So therefore, if diversity factor is more, plant capacity is reduced, therefore investment required on that plant is reduced, we will have lower cost of generation. So our conclusion is that both load factor and diversity factor, they should be high in order to have lower cost of generation. So correct answer, it will be option B. Question number 56. Maho relay is normally used for the protection of long transmission line, medium transmission line, short transmission line, or transformer. We know that distance relay that are used for the protection of transmission line, they can be classified broadly in three categories. That is the impedance relay, reactance relay, and Maho relay. Out of that, for short transmission line, we use reactance relay. The reason of using reactance relay, because its reach is independent of fault resistance. For medium transmission line, we use impedance relay, whereas for long transmission line, we use Maho relay, because its characteristic is very much suited for long transmission line where there are chances of power swing. So Maho relay occupies a least area in a RX plane. So therefore, during power swing, unwanted tripping chances are reduced. So also it possesses the directional property. So therefore, Maho relay is used for long transmission. For transformer, as we are aware, we use a differential relay as a primary protection. Also we use Buchholz relay and other relays. So all these three are a distance relay. Question number 57. The incremental cost characteristics of two generators delivering 200 megawatt are as follows. df1 by dp1 and df2 by dp2 are given. For economic operation, what should be the generations of each unit? That is P1 and P2 should be. Now we know that for most economic generation, that is to have minimum cost, the incremental fuel cost of each unit, it should be same. That is df1 by dp1 should be equal to df2 by dp2. So we have given these equations. If we put this, so 2 plus 0.01 P1 is equal to 1.6 plus 0.02 P2. If we simplify this, so 0.01 P1 minus 0.02 P2 will be equal to 1.6 minus 2, that will be minus 0.4. So if we simplify by multiplying by 100 on both sides, so P1 minus 2 P2, it will be equal to minus 40. So that will be equation number 1. That is the one equation. As there are two unknowns, we require one more equation. So what they have given, that incremental cost characteristics delivering 200 megawatt, meaning is that these two units combiningly they are delivering a power of 200 megawatt. So P1 plus P2, it is 200. So what we can do, we can subtract equation 2 minus equation 1. So if you do equation 2 minus equation 1, so on RHS, so P2 minus minus, it will be plus 2P2, that will be 3P2, that will be equal to 200 minus minus plus 40, that will be 240. So P2, it will be equal to 80 megawatt. And if P2 is 80 megawatt, the remaining power will be delivered by the first unit. So P1, it will be equal to 200 minus 80. So that will be equal to 120 megawatt. So P1 equal to 120 megawatt, P2 equal to 80 megawatt. So correct answer, it will be option D, 120 megawatt and 80 megawatt. Moving ahead, question number 58. What is the reserve capacity if the maximum demand of generation of power is 50 megawatt, the load factor of the plant is 60% and the capacity factor is 50%? The question is asked in Mahatransco AE exam in year 2022. Now here, whenever such problems are given, as I have told that we write the equations of whatever quantities are given. So here we have given the load factor. So we know the load factor, it is a ratio of average load divided by maximum load. So load factor is 0.6, average load we don't know. So average load keep as it is, divided by maximum load, maximum demand, it is 50 megawatt. So from this, our average load or average demand, it will be 50 into 0.6, that is 30 megawatt. Now another quantity is given, that is capacity factor. So capacity factor, it is a ratio of average load to the plant capacity. So putting the values, so capacity factor given is 0.5, 50%. Average load we have calculated as 30 megawatt. So plant capacity we can calculate from this. So plant capacity is equal to 30 upon 0.5, that is 300 by 5, that will be equal to 60 megawatt. So maximum demand is 50 megawatt, plant capacity is 60 megawatt. So reserve capacity will be 60 minus 50, that is 10 megawatt. Because we know that plant capacity, it is always higher than the maximum demand and it is higher by the reserve capacity. So this is the equation. So from this, our reserve capacity, it will be equal to 60 minus 50, that is 10. So correct answer, it will be option B. Now next, question number 59. This question is asked in the GATE exam year 2003. A list of relays and power system components protected by the relays are given in group 1 and group 2 respectively. Choose the correct match from the 4 choices given below. Okay, so I will not read all the 4 options. So here if we see from the easier one, the Buchholz relay. So we know that Buchholz relay, it is always used for the protection of transformer. So there should not be any confusion. Buchholz relay is the only relay that is used for the protection of a transformer. It is not used for a turbine, busbar, capacitor, alternator or a transmission. So for S, matching pair, it will be transformer. Now coming to the distance relay. So distance relay is used for the transmission line protection. So this P we can map to 6, that is transmission. Now this under frequency relay, it is used for the protection of alternator, because alternator on one side there is a grid and on another side there is a prime mover, that is a turbine, and frequency plays very important role. If frequency changes, we need to take the proper action and we need to have the load frequency control. If frequency falls below a certain range, then under frequency relay will give the trip signal. So under frequency relay is used for the protection of a alternator. And coming to the differential relay. So differential relay, out of these 3 options, the differential relay, it is used for the busbar. For busbar protection, differential protection is a primary protection, because it is a unit protection. Busbar will have many incoming outgoing lines and it will check whether sum of incoming current and sum of outgoing current, whether both are matching or not. If it is not matching, meaning is that there is a fault on a busbar itself and that relay will operate. In order to sense that particular difference in the current, we use the differential relay. Differential relay is also used for the transformer, but here in this combination, the Buchholz relay is more correct for transformer. So for P6, for Q5, for R3 and for S1. So correct option, it will be option A. So many MCQ questions can be formed based on this single question itself. So next, question number 60, it is asked in ESE 2013. The advantage of hydroelectric power station over thermal power station is: the initial cost of hydroelectric power station is low, which is not correct. The initial cost of hydroelectric power station is more as compared to the thermal power plant, because hydroelectric power station requires a lot of civil cost. We need to build a dam, therefore initial cost is large. The operating cost of hydroelectric power station is low. That is correct, because here there is no need of fuel. We use the water and we use the potential energy of water. So water is freely available. So operating cost is low. Also, it is very quick starting. The starting time of hydroelectric power station is hardly 1 to 2 minutes, whereas in thermal power station it is in hours. 18-20 hours are required. We need to start the boiler, and then there are many stages. Then electricity will be started. Generation of electric energy will start. The hydroelectric power station can supply the power throughout the year. That is also correct depending on the water availability. But if we compare with the thermal power plant is more reliable and they can supply the power throughout the year. Hydroelectric power station can be constructed at the place where the energy is required. That is not correct, because hydroelectric power plants are usually located in hilly areas or near to the river, and load center may not be close to the river or hilly area. Therefore, we need to transport that energy long way from the dam to the load center or the hilly area to the load center. Therefore, option D is not correct. So correct answer it will be option B. Thank you.